Today, we're going to attempt a
I recently watched one of Dan Wood's videos where he used ChatGPT on his C64. To do this, he dialed up a BBS, which has ChatGPT functionality built into it. I want to get my C64 online as well, and I finally got inspired enough to do so. So in this video, I will make a user port modem for my Commodore 64, so I can start dialing BBSs too.
But of course, the big thing is that we'll need to be connected to the internet to access...
There are multiple ways to get online with the Commodore 64. In Dan's video, we can see him using the 64 NIC+, which is a modem with Ethernet. There are multiple modern solutions that you can either buy or build yourself. You could also go old school and use an original Commodore modem that uses the phone line. I don't have a phone line, but I do have Wi-Fi, and I know I've seen projects online that uses the ESP8266 module from Espressive to build Wi-Fi modems. And that's what I want to try today. My goal for this project is to make a working user port modem using only parts that I already have in the lab, because I hate waiting for parts. So after doing some research, I think this blog post from the blog 1200 Boards by Mr. Admin, I guess. This is going to be our basis for the build. We can see here that it utilizes the ESP8266, although it seems like they're using the NodeMCU, which I've never owned or tried or anything. Let me find the module that I have. That was the wrong one, that's ESP32. To be honest, we could probably use an ESP32 as well. But we would probably have to modify the firmware. Let's just stick to the ESP8266. And these are the modules I have. I have some black ones and some blue ones. Let's see. There's no name on anything, but I think they're called... But yeah, I think it's just called ESP-01. That says ESP01 adapter. So that should be it. We're not going to use this, I think, but we do need to use this, which is a programmer for the ESP-01 module. You can just hook the ESP module directly into this, and you can program it over USB. So this has the USB to UART adapter on it. So NodeMCU, though any board with GPIO breakouts including 4 and 5 should work. Yeah, so there's our first issue, because this has basically no I/O. It has 3v3, it has ground, it has TX and RX, reset, and then just IO0 and IO2. And those are used for programming. So we only have 2 GPIOs on this, but I think we can still do something. So here's the connections we need to make. So the ground, that's fine. TX to the C64 RX. So I should go to port B and C. And then we have the TX from user port M to RX on the ESP8266. So we have both TX and RX. That's fine. We also have some connections here. GPIO 4 and 5, like they mentioned. We have GPIO 2, but it doesn't matter when we don't have the other handshaking pins. We're gonna have to try and make this with no hardware flow control, and I think that should be possible, as long as we keep the baud rate low enough. Optional power from C64 connects C64 pin 2 to ESP8260W, not W, VN. This module takes 3.3 volts, so we can't connect it directly to the Commodore. We need a voltage regulator. That's about it. So, let's see what we have. So we have the ESP8266, perf boards, breadboards. I have hookup wires. I recently bought these from eBay or Amazon. They are the AMS 1117 voltage regulators on a small breakout board, so they should be perfect for us in this case. Has everything we need, just 5 volt and ground in, 3.3 out. So that should be perfect for powering, and it's small, very small. So these are our components. I think this should be the bare minimum we need. And this will also allow us to power the ESP8266 directly from the Commodore. So we need no external power sources or anything. One more issue is that the ESP8266 is not really 5 volts compatible on the GPIO pins. TX to the Commodore, that's fine because the Commodore will handle the 3.3 signal as a high signal. That should work fine even though it's made for 5 volts. However, the TX from the Commodore is 5 volts and the ESP8266 is not 5 volt compatible. But in my experience, they do seem to handle it quite decently. I've actually had no issues with that in the past. That being said, we might just do a voltage divider to bring down the TX signal from the Commodore to the 3.3 volts expected by the ESP8266. If you don't have this voltage regulator, you could also just power the ESP8266 with maybe some coin cell batteries. They're usually 3 volts. Maybe it might actually boot with 3 volts, so that could be worth a try. So my first idea was to take the perf board and the edge connector, some headers, and try and make a just like a what should you call it, a development board for the user port. So I just wanted to add the edge connector here like this, and then bring out all the signals to some headers. And it ended up very tedious trying to route all the signals on this like two-sided perf board and the edge connector. So I scratched that idea, and then I ended up making this instead. So this is basically the same thing, just very simplified. I soldered the pin headers directly to the user port connector. I just removed the pins that are not in use. You can see that they actually line up quite nicely if you just remove some of the pins. So this should get us started quite fast. Now we can just connect this to the C64, hook up the signals we need, and get a proof of concept going. So let's try and make a proof of concept here. I like to just do things as easy as possible at first, and then we can build on that later and try to improve on things. So we have our user port with the user port connector with the headers, which are already labeled, so we won't make any mistakes. It's also important to make sure to have the right side up when you connect it, so I wrote up. I also have the blog post as reference there. So ground should go to pin N, like so, and we just put that on the ground pin here. This one. I also made this, which is a 1 to 3 pin connector thingy, because TX from the 8266 should go to the user port B and C. So we hook this up to B and C, like so. Those should go to ESP8266TX. Let's use orange. So we put that into TX, that's next to ground. And then we do the RX, use green for that. The RX is this pin right here. And that should go to TX on the user port, which is M. Then we have the hardware flow control stuff, which we just skip. M to 5, this is part of the hardware flow control as well. So we're not gonna bother doing that. And then it's the power. So I don't want to try and power the 8266 from from the Commodore with 5 volts, because I think that would be a bad idea. So we could try with a coin cell battery then. Let's take one of those. Now to make that easy, we just take the 3.3 volts there. So we have our 3v3 on this red hookup wire, and we need another ground. There's no more ground pins on the ESP, but there should be more grounds on the user port. Okay, so this is the pin reference for the user ports. So we can see that we already use N, but we have a ground on A. A is a bit obstructed by this 1 to 3 adapter I made. So, but we also have ground on pin 12 and pin 1. Let's just use 1. So that should be it. Now we have these two for our external 3.3 volts. We'll use this battery. But before we can do anything, we need to program the ESP8266. So let's get that done. So this is where this programmer is going to be useful for us. The annoying thing about this is that the female pin header has 2 extra pins, and it doesn't really say where the module should go. It could go like on this side, it could go on this side, it could go either way. So it's kind of stupid. So that's why I have this cheat guide here. So it should go like this, and we had a blue light there. This might be programmed with something from before, I'm not sure. So let's try and program this. I'll head over to the PC. Okay, so I have opened the Arduino IDE. I have the Wi-Fi 6.4 virtual modem loaded into the IDE. We should be able to flash this. Now when the upload starts, I need to hold the reset button on the programming board that I'm using. So I hold this button, let go, and it's not working. So let's see if we can get this to work. You can see that I haven't been able to program here, and I think that's because I need to hold the reset button when the upload starts. So I'm holding the reset button, and it does not work.
A few moments later.
Okay, I guess it was already uploading. Why did I try to reset? I think you needed to hold down the button. I think this 8266 may just be unprogrammed, so it actually just boots into the bootloader and the upload starts automatically. But when it's already programmed, you definitely need to hold down the reset button to be able to start a new download. But that seems to be succeeded. I opened up the serial monitor, and we can see, as it said in the blog post, we need to configure the Wi-Fi, and we also need to configure the baud rate, so we don't have to use the very slow 300s. We can't go up to 9600s because that will not work without the hardware flow control, but I think we should be able to go to 2400s. Anyway, so we do $80 SSID to put in our SSID and $80 pass to do the password. Use the commands AT and P0. Okay, I think that is related to the hardware flow control, so we're gonna skip those. Hello, this is Hog from the future. What I was just saying there is wrong. We do need to disable flow control, and we do that by setting AT and K0. I also set the pin polarity to normal, and you do that by using the AT and P1 command. I think that's only for the actual hardware flow control pins though, so I don't think we need that. Anyway, let's go back in time again. And then we do $80 SB equals the baud rate. And AT and W to write these settings to the EEPROM. Okay, so let's try and do all of that through the terminal in Arduino IDE. Okay, that seemed to be working nicely. We changed the baud rate to 2400 and we are connected to my Wi-Fi. Let's try and hook this up to the C64 and see if this minimal solution is going to work. I'm going to be using the CCGMS terminal program for the C64 that can be downloaded in multiple places. It's on this Commodore software site and you can also find it on GitHub. So I'm going to hook up the modem to the user port now and I'll turn on the Commodore and let's see what happens. Okay, so I'm already loaded into CCGMS. I'm just loading this through my Kung Fu cartridge, so it loads up when I start the C64. If we press return, we should be able to see the output from the modem, but we need to power the 3.3 volts first. So let's try this battery. Okay, let's take the ground. I do not think that is enough power. Oh, we actually got something in the terminal. But I don't think this is enough power for the... So we can see it. You can see it on the camera. We can see it flashes blue very fast and gives us some garbage on the screen. So that's not booting correctly. I mean, this is all just for fun, because we could just obviously use the voltage regulator, but what else could we do? We could use the lab power supply, but that's kind of cheating. Okay, so I'm looking at the datasheet for the 8266, and we can see that the maximum voltage is actually only 3.6, but the minimum says 2.5. So it should work with the coin cell, but I think it's just drawing too much power. Okay, so I have this battery compartment with two standard AA batteries. This should be 3 volts as well. And it certainly isn't. Is this broken maybe? Did I put them in the wrong way? Oh, it has a power button. Okay, so we have, oh, that's 3.2 volts. So that should definitely work, and these should be able to output more power than the coin cell battery, I guess. Let's give that a try then. This whole setup is pretty janky, but let's see. We are experimenting. Okay, so we have a blue light on the microprocessor, that's good. See if I can do all of this with one hand. Let me check the settings. Okay, so baud rate is set to 2400 and we have modem type user port. So let's go back. Let's do enter. Oh, look at that.
It freaking works.
So that actually works then. Alright, so we just proved that this is the bare minimum of components you need to get the Commodore 64 online, even though at a pretty slow speed and a very janky setup. And also you're taxing the GPIO pin on the ESP8266, the RX pin, and you also might be draining too much current from the RX side, no sorry, the TX side on the Commodore. So we obviously want to protect the Commodore hardware as much as possible. So I think we need to improve on this. But I mean, if you're in some kind of post-apocalyptic situation and you need to get online on a C64, this is the setup.